what we see a lot out there is, from a NSX perspective, is how to set everything up in the virtual world. And we're talking to some of the folks on LinkedIn and some of the other places, and they would like to see how it connects into their world. So that's what this webinar is going to be about, is a combination of a little bit of background on how some of the routing protocols work, and also getting into what the physical network configuration looks like. So, as they say, let's get moving. If we didn't have the classic Visio diagram to start things off with, wouldn't really be a classical network discussion here. So this is what the physical topology looks like. We have router 1, router 2, router 3, and router 4. From a network perspective, NSX is just another router on the network. See how that's why I didn't name it like router 5 or something like that. It's actually what we have in VMware or in NSX. It's called a Edge Service Gateway, and this gateway has a lot of other features, but in this webinar we're just going to cover the feature set of how routing protocols are able to communicate between the different networks. And for you folks that are wondering why that little line is running between router 1 and router 2 that's separate from the actual interface, that's actually on there because in some of the routing protocols there are differences between what is called an intra-area, which means it stays inside of the area, versus an inter-area. So the cost and how it would actually move things around are different, and that's why that link's there. So let me jump ahead and I'll show you the logical setup. Now, from a logical setup, we're going to make the NSX world a area 100, and that's a not so stubby area. And we'll cover what all of these fun network-centric terms are in a little bit here. But the reason for doing it, it'd be way too simple to just make them all what is called a normal area, and you're not able to say, hey Neil, hey Ron, what's the difference between a normal area and a not so stubby area? And that's what we're going to be covering here. Ron, did you want to throw anything in on this slide before we hit the next one?
So just real quick, I wanted to mention that we do have an interactive Q&A window, so if you type your questions in there, we'll respond to them as we're going through and make sure we get all that taken care of for you. But yeah, I mean, this is going to be some good stuff, right? I can see we were going to talk about OSPF. You mentioned it with the intra-area and inter-area conversation earlier. You got IBGP, EBGP, man, we got it all going on. This is going to be a fun conversation.
Yeah, and again, the NSX Edge Service Gateway has got a ton of other features to it. In this one, we're just covering the feature that allows you to go from the virtual to the physical world, so that when you do your pings, and you get replies from machines that are still that are out in the virtual world, say a workstation, another set of virtual machines that aren't part of NSX, for example. So, just to give you the really, really high view of what's going on is you have a normal area and a not so stubby area. So what this allows you to do is to abstract what routing information goes into an area or into the different areas. So like area 0 is like the one ring to rule them all. That's what we would call the backbone area. So
exactly.
Yeah, and you notice it wasn't by accident here that area 200 touches area 0 and area 100 touches area 0, and that if you try to do it other ways, where you say had area 100 touch area 200, then touch area 0. Wow, anything's possible with you know, stuff that starts to take you into the more advanced, I guess is a nice way of putting it, the more advanced ways of making things work when routing wasn't planned out or areas weren't contiguous, so to speak. And this right here helps you to make sure that you're touching area 0. Now, I'm kind of a traditionalist, and Ron may agree or not agree, but I'm not a big fan of having area 0 outside of a set of routers that are essentially in the core of the network. So I try to have area 0 be at the center or the core, and then from there attach the different areas. What this helps us from a networking perspective is this helps with what's called flooding between the different areas. So if you have somebody that is generating hundreds and hundreds of routes, and they're going up and down as you're adding and removing machines if you're using APIs or something like that to add networks and at a high rate, you really prefer to have these things flooding, which is into their area, instead of going into area 0 and then area 0 having to calculate things to head out. One of the things I've got over here to the side I wanted to make note of is the OSPF type 7 to type 5. It may be like a little bit of trivia in that the not so stubby area uses type 7 LSAs, which is a term for OSPF and how it's able to build its database and how things work. But when it goes out of this area and then it heads into what is called a normal area, it's going to convert that from a type 7 to a type 5. And you're like, hey, Neil, why the heck is that so important to me? Well, the reason it's kind of important is that one of these machines, router 1 or router 2, is going to be the part that's going to convert that from one to the other. And it's good to know where it happens so that you can set up through priority or however you need to say who's going to be the primary so that you can like look at it on a Visio and who's going to be the secondary. So from a troubleshooting perspective, if you don't set it, then OSPF does its best to figure out where to put it, and sometimes where it puts it might not be where you think it's at. So that's a part to keep in mind is the conversion from the not so stubby to the normal area. One of these routers is going to make the conversion for you to the different one. Let's head on to the. Oh, yeah, go ahead.
So
go ahead, Russ.
Just real quick on this. I think one of the things that's important to kind of point out, and you've mentioned it, is that OSPF in and of itself is very, very specific and very much I look at it almost as a taskmaster with regards to how it wants you to design your network to be successful, right? You mentioned keeping area 0 relatively small in the core, not having it span a ton of devices to help it scale and to help minimize flooding. And there are a million different ways to do OSPF designs. But and I've seen probably a lot of them of what not to do, right? But definitely there's some pretty specific requirements for area adjacency that Neil hinted at earlier that you want to definitely keep in mind. And truly, and how this relates all to NSX comes down to we want to keep it very simple. We want to keep it very scalable, and that's why we're going to talk about NSSA and why we feel that that's a great use case for OSPF inside of NSX to physical topology to help maximize the scale, minimize flooding, and also kind of to help keep everybody from the networking side from freaking out about having this virtual router now added to their infrastructure.
Exactly. I mean, there's a lot of options. We could turn this in instead of it being a physical to virtual, we could turn this into just a OSPF webinar with very, very little effort, in that NSSA has a lot of features to it that help you to minimize the routes that go into NSX or into a not so stubby area. In that, in the examples I'm going to show you, I didn't turn it on where you could say just send what's called a default candidate or default route into the NSX edge instead of sending any other route. And that has a single route that comes in. And now one of the things that's it's always a plus and a minus is like, oh, why, hey, why did anybody invent NSSA in the first place? What is the big difference to me between normal and NSSA? And the big difference to me is that you don't have accurate routing telemetry. So an example would be if you have only a default candidate coming in from router 1 and router 2, and it goes, oh, I'll just send it out one or send it out the other, it's not getting enough information. They could say, hey, maybe the connection to router 2 and router 3 is running over a 100 gig connection, and the connection between router 1 and router 3 is running over 100 meg connection. That part is kind of lost in the when it's bringing the information down, and that's the kind of stuff when you're doing your topology and you're really starting to lay out your networks, is that network visibility that OSPF brings between the different kinds of areas into the factor. Because if from a simplicity standpoint, just sending down one route, really, hey, look, that's all I'm sending down is one route from router 1 and router 2 to the edge, and northbound from the edge I'm sending up my routes, may sound great from a simplicity standpoint on my network diagram, but if the speeds are different or other characteristics are different, that visibility is lost when you're switching from a normal to a not so stubby area. Let me take you on a little bit here, and yeah. So now that we've covered what the high level of what the network looks like and what the logical looks like, we'll back up a little bit and tell you a little bit about what NSX is. As you saw earlier, there really wasn't an easy way to be able to say what the difference was between the physical network and the virtual network. And that's really what NSX is trying to do, is become a faithful representation of your current network, except you won't have to rewire when you want to add new VLANs, or you'll not have to go and do a lot of additional changes to each one of your switches that are in your infrastructure. You would actually be able to say add a new layer 2 network for your web servers, and then you attach it to what we'll show you in a little bit is a distributed logical router, and then from there that route automatically goes up to the edge service gateway that you've seen me and Ron show you quite a bit so far, and that automatically advertises into your current network. So being able to add a new network to your existing infrastructure is going to be right up there, as simple as when you created a new layer 2 network and you just say attach it to a router, that router automatically sends it up and it's available on your network. So there's no having to go configure VLANs or do what they call HSRP or some kind of NIC top redundancy protocol where that's your default gateway. All of that stuff is handled inside of NSX. Is there anything else you want to throw in there, Ron?
That's the biggest thing, right? And that's one of the things I think a lot of people kind of struggle getting their head around initially is, wait, I don't need HSRP or any other first hop redundancy protocol, and that's pretty cool. That's a great feature of NSX.
Yeah, yeah, and one of the really nice parts about it is it's across all of the hosts that are running it. So I don't have to go find out which one's primary or which one's standby or tertiary. Every single one of them is running my my default gateway. Every single ESX host that has NSX installed is going to be able to participate in this, and that really makes things a whole lot easier to set up. So the routers that I was showing earlier, that edge service gateway is a single router is a point to leave the network, but the distributed router, it is across all of the ESX hosts, which is really nice. So let me give you a quick view of what it looks like. This right here, the demo Edge 01 from our earlier diagrams, and I'll make a note to make sure that we have the configurations for the Cisco routers as well as any of these diagrams, so that you're able to take this back and internalize it and modify it for your network. The demo Edge 1 that I have on the screen, or Edge 3 is its ID. That's the one that we've had in our diagrams. The one that Ron and I were talking about just a moment ago is the distributed logical router, and this is the one that runs on all of the ESX hosts that have NSX installed on it. This is what allows us to have a default gateway available on every single host, so it doesn't have to go all the way out to the physical world and then come back. That's one of the really, really game-changing aspects of NSX, is that it only needs to leave the environment when it needs to leave the environment. So if we have 3 or 4 layer 2 segments and they're all NSX enabled, they don't have to leave the logical construct that we're creating here unless it needs to physically leave the environment, like it's going to a workstation or somebody out on the internet. All of the other parts stay internal. So if you have 2 hosts, for example, that are attached to this distributed logical router, exactly like the world is now with normal routers, if you have 2 hosts that are on 2 separate subnets and they connect to the same physical router, they don't have to go somewhere else to figure out where to go. They're able to route that traffic on their own. And we're just taking that up to the next level with the distributed logical router, in that it's able to stay on the same host. So you start being able to pick up things like, okay, I'm going to put the web server and say it's very noisy database tier on the same physical host, and they will be able to route just fine and not have to go out of the that infrastructure and say go up to router 1 or router 2 and then come back into the infrastructure. Anything you want to throw on there, Ron, before we really start getting into this stuff?
Yeah, I'm anxious to see this stuff in action, man. Let's see what it looks like.
Yeah, for sure, for sure. All right, I just wanted to give you for the folks out there that are used to the CLI, and if you've got the PowerPoint or PDF file pulled up on your desk while you're watching this, this is the representation of it from the Edge Service Gateway. Here's where we set the area ID that we say it's a not so stubby area over under type. We just hit the plus sign and add in the actual virtual NICs instead of having to create a VLAN, then create an SVI and create all the HSRP and all of that stuff. We're able to treat this one just like a virtual machine, except it's a virtual router. So you can add your NICs to here to this. This is my naming structure because I got plenty of the 1 and 2 a.m. calls, so you can see that I call this one 10.10.23.0, so that's a 10.10.23.0. It's got a 24-bit mask, and it's part of VLAN 23. And, terribly imaginative there. But that tells me that this is a physical VLAN-based machine, or VLAN-based hop out, whereas 172.16.24.8 is, since it doesn't have a VLAN on it, that's VXLAN based. So that's how I'm able to determine what the differences are, and that helps me to map them and keep my Visios reasonably, reasonably in sync with the network, because there's no change in how things are set up on that. Let me pop over here to the next slide, and then wait for it to build. Okay, one of the and this one right here, the reason I like to throw this slide in is that folks are like, hey, what about firewall? I need to get my stuff out to a firewall, and how does all of that work? Well, in NSX you have the hypervisor. Then you have the virtual switch and the physical switch. That's like we're going to connect outside the environment. But in the actual hypervisor itself, we have what's called a distributed firewall. This isn't part of the edge gateway, but what this does is this gives you the thought process. Okay, I don't have to route out of my infrastructure to go to a firewall to have an access list just to route back into my infrastructure. This has the ability to sit right above the what we call the V switch, which is a layer 2 switch in virtual terms. We've had it in ESX for forever, and this allows you to redirect. To ours is the one I have labeled as DFW, but we can also, if you choose to, you can have it redirect into some of our third-party feature set, which they do the deep packet inspection, or into an IDS IPS, and this what this does is it actually reduces your bandwidth outbound, because all of this stuff again is done inside the host itself. So I just want to keep that in mind. So you're like, hey Neil, how is this going to work if I got to run through a firewall? Well, the firewall is actually like is shimmed in right above the vSwitch and right below the VM. So yeah, we've got the firewall taken care of as close to the actual machine as you can possibly get. Just to reiterate before we start getting into our demos, which is always the fun part here, is this is how we're set up. So we have the not so stubby area. I showed you the configuration, and I'm going to walk through the distributed router a little bit here in a second, but I just want you to keep this in mind, because we're covering so much information in relatively short amount of time, that when I start getting going on these demos here, I need you to keep this in mind, that this is how it's set up, and then I'm going to walk you through how the configurations themselves work. So here we go. Let me get the DLR going here. So just to show you how you got to, I'll get there. It's networking and security. And we're going to go, I'll get there in a second. There we go. Edge switches. And this is what you saw in that picture just a little bit ago. Now we have the edge and the distributed logical router. We're going to go into the DLR because it's not part of the subject or what we're talking about today, but I wanted to show you how it looks. Now we've got the configuration, and I'll show you the interfaces. See, I have that 192, 68, 26, and 27 there. You're going to see those show up on the physical routers here in a little bit. And let me hit the routing. And we're running OSPF, and we hit the global. Here's the router ID. That's one of the things that you have to set in order to make sure that's what it's using to figure things out. Let me go back to the OSPF real quick. Now we have the protocol address and the forwarding address. Then, let's see. Now let's see. Then we got the area 100, and then you see how I have just the area interface mapping. That's what's used to map area 100 up to the edge service gateway. That is, the main focus of this. But this is how things, this is how visually that you're able to go and set up the different sections of OSPF. From this point on, if I need to add another interface or need to add more to it, it would be under the, like, from route redistribution. There's a whole ton of things that we could get into as far as what this could do. Hey, Ron, did you want to throw anything in about the protocol and forwarding?
Yeah, exactly. That's what I wanted to call out was, it might be some confusion for some people about, so what exactly is that, right? So the forwarding address, the easiest way to remember it is actually programmed into the DLR on every single host, right? So that's the one that does the data plane operations. And then the protocol address is just there for the control plane aspect, right? So in this case, .14 is the protocol address that we're going to use. So it's not a real IP that's actually bound to any devices other than it exists on the DLR control VM. But the forwarding address is what's going to be programmed into all of the into the DLR of all of the hosts inside of that particular scope of that DLR.
Yep. Yeah, and see how we're keeping everything in area 100. So we trying to keep it nice and simple and straightforward. Let me get onto the edge side here. I just hop right into it a little bit faster. But this is what they look like. This is the interfaces. Let me hop on routing real quick. Again, very, very straightforward. Wait for it to catch up for me. There it goes. Yeah, very, very straightforward. There's your area 100 that we were covering earlier. Now I'm just going to add it in and see how it picks it. Pretty much picks it for me. So again, we have our ever classic areas. So now it's added. Now I'll add in another one because from our diagram, we only had two links. So you have your northbound and you have your southbound. And I'll publish the changes. And that is, as crazy as it is, that is the extent of simply bringing OSPF into the infrastructure. So just to recap really quick from previous diagrams, we had the distributed logical router that had area 100 on it, and it was set for the in its northbound was 172.16.24.8.29, and that of it, and this is the edge gateway. So then that becomes the southbound interface, and then we covered a little bit on when I was showing you the pictures for VLAN 23 that walks us through. Let's hop over to one of the actual physical routers real quick. And this is router 1 from our diagram. So it's one of the ones that's what would be a ABR or autonomous area border router. And let me show you what the configuration looks like on this one. See, there's the 127.2.3. Those are my loopback interfaces that are on it. It's not showing us .1 because .1 is the itself, so that wouldn't be OSPF. That would actually be a connected interface. But to keep things simple, I'll just walk through it the configuration a little bit for you. The router ID, or it says router OSPF 10. That's us just making the process ID. The router ID, I have a preference for using the loopbacks, and this kind of comes in if you ever switch from OSPF to BGP. It's I would say it's a very, very good idea to use the same router IDs, because then as soon as you don't, you'll find out it was a bad idea because it's not working the way you want it to, so then you'll just end up setting the router ID to be the same between your protocols anyways. So anyway, I use 10.127.127.1, so that's router 1's loopback. That just helps me to remember what it is. You'll see the network 10.127.1 there. That's just me advertising my loopback into OSPF, and that part that doesn't make much sense up above where I did the show run and then I did a pipe for the section for OSPF. That OSPF network point-to-point is there for the loopback so that it will advertise it correctly or look correct. The default information originate that's all the way at the bottom near where it says demo-RTR1, that's to send the default candidate into the infrastructure. Now, we haven't actually added in the virtual infrastructure yet. So, that's, just giving you an idea that this is what it looks like before anything is added to the infrastructure. Do you want to throw anything in there, Ron?
No, it looks like typical OSPF, which is exactly what we expect, right? Nothing magical or mystical about it. Pretty straightforward.
Yeah, I really resisted the urge to nerd it out a bit. So that's why it's not 65 lines long. Let me get on to router 3 here, and router 3. Let me hop over there. Let's get on this real quick. Finish this off. Yeah, I might as well since it's running low on time. Let me make a quick change here. What I'm doing right now is, while I'm talking and typing, is that we're telling the physical router that area 100 is not so stubby. If you don't tell it what it is, then it will not. It'll assume normal area, which is not how we have it configured. So it's not gonna try a bunch of different types to figure out what to do. So here I'm going to put in that the 10.10.23.1 interface, and I do it by the interface instead of by networks and stuff like that. It's just a little quicker for me. And later IOX, XR, and all those, they did it that way anyways. But I'm adding in the 2 interfaces that are part of area 100. The first area, or the 10.10.23.1, is the one that goes down to the edge gateway, and the 172.16.24.0. And yes, I use /31s. I'm really stingy on my IPs, even when they're.
I was just going to say something. That's awesome. /31s are so cool, and I love the fact that we support them in NSX as well. So
yeah, and I'll give you guys that are on here that are like, hey, what are those 2 nerds talking about? So a /31 doesn't have what's called a network and a broadcast area address. So what it's like when you do a ping of whatever subnet .255, it pings everything. That's a broadcast, and the .0 is normally the network. When you use what's called a /31, it just has 2 IP addresses, so you don't waste those 2 other IPs in setting it up. So it allows me to use, in this case, say the 172.16.24.0. I can slice that up and literally create 128 or 256 divided by 2. Yeah, 128 little subnets that I can use, and I keep all of my point-to-points together. And that really helps to keep things nice and tight as far as, if I see a 172.16.24, I know that that's a point-to-point network on mine. And down below, one of the other parts that I wanted to bring up, it's kind of, if you see this thing called priority, basically, it's another one of those trivia things, higher priority wins. So, you can manually set that on whichever side, the physical side. If you make it a higher number, like 129, it would be the owner. And when you see some that say like the other, that means that it's the designated router. So in OSPF terms, there's a designated router and a backup designated router. That's the DR and the BDR, and those are the ones that pretty much control what's goes where and all of that. So if you're setting up your network, that helps to know where those are. So you can use priority to set those. And as you see on my neighbor IDs over on the side, the 10, 127, 127, 2, and 3, that correlates to router 2 and router 3. And just to be, I guess, different, but the 10.10.23.2, because there isn't a concept of a loopback, so to speak, on edge service gateways, you define that as to what the interface is. So let me hop over here real quick. I'll go on and we'll take a look at let it catch up here a second. There we go. Get over on router 2. And router 2 is just a pairing of router 1. So I'll just, it's going to be a little redundant from what I was showing you earlier, but it's always good to have the configs. And you notice that 192.168 all of a sudden popped out of nowhere. That's because we have a neighbor relationship now with the edge gateway. But it's kind of taken a weird path, isn't it? That's because this router has not got a connection to the edge service gateway southbound. So keep that in mind when you see that OE2, and see that 192.168, 26, and 27. We're already connecting to NSX, but the path is not what we would think it would be. It should be like a 10, 10, 20 or something like that. So as we add in the configuration, keep that in mind, and we'll run it here in a second so I can talk and type at the same time, or try to. We'll let it finish off here. Copy and paste is my favorite way to do things.
Oh, yes.
It's hard to make a typo. And
if there's a way to make a typo with cut and paste, I'll find it.
Oh, I've done that too.
Oh, yeah.
Because my source info was wrong. Eek.
Exactly.
All right, so let's, I'm going to do the, it's got to type in the right one. Let's try 26 and 27. See how it changed? Now it's pointing to the edge service gateway. So it knows, hey, wait a minute, I found a shorter path. And that's what happened. And that's one of the things you have to kind of plan for when you're bringing on multiple routers, that as they're converging, things like that are, it's going to happen. So, just keep that in mind. So far, the next little bit that we're going to cover is just going to be showing you more things on OSPF, but for all intents and purposes, at a high level, we're done with, the configurations for OSPF, and it's now on your network, and it's actually using the best path to get there. And that's one of the things when you're first setting it up, is to make sure to come in here, like I've got here on the screen right now, is to make sure that where it says, for example, 192.168.27.0 is going via the path that you expect. If it's not going that way, that means it's learning it from somewhere else and it's not learning it directly. So let me pop over, and I'm going to take you over to one of the edge service gateways, so you can see what it looks like, over there. It's like I have to hit enter. Yeah, there we go. Yeah, show IP route OSPF. See, we're showing up as intra areas. There's our there's the loopbacks. And you're like, hey, where's 1 and 2? I'll get to that. Now we'll hop on the DLR real quick. And remember, that's the one that's on all of them. See, there's 1, 2, 3, and 4. So we're seeing all the loopbacks from the rest of the infrastructure. You're like, hey, there's 3 and 4. Where's 1 and 2? Well, there's more commands that we could type than just show IP route OSPF. We can just do a show IP route and static. And I staticked those because a little later we're going to show you BGP, and I like to use the loopbacks, so I put a static route in to the loopback interfaces of the routers. Show you what looks like over here on router 3. And router 3 is like the core of the network. So notice that we're starting to see there's 26 and 27, but see now that there's 2 paths to the so now we've got 2 paths to the same location. So router 3, if you're looking at the diagram, can use router 1 or router 2 to get to the edge service gateway. And that's kind of how it learns what the different hops are in the network. And that's the same thing up here on 10, 10, 23, that it knows that there's 2 hops to get there. And that's what it's using. Oh, I have to go out this fast Ethernet or whatever interface it is to actually get there. And this helps you to balance your traffic across the different interfaces. Let me show you real quick what it looks like on the next one, since we've got it here too. Let me get it going. Router 4, I don't want to leave router 4 out, because router 4 is a not so stubby area as well. We came through a normal area and then a not so stubby area. One of the crazy parts that's missing out of here is, hey, where are those 192, 168 routes? Why aren't they there? Well, this is one of the things about using not so stubby areas, is that the type 7s get translated to type 5s, and they don't go into the area. And the reason that this N2 is even here is because I did a default candidate route. So that's where we were talking earlier about that not so stubby may not have a good view into the networks of all of the possible paths, but it works great using it as an edge.
Well, and that's a great example too of a scalability technique, right? You don't necessarily need to have every route everywhere all the time. Maybe in the all-seeing, all-knowing, core, the one ring to rule them all, but not necessarily all of your edges, right? Especially in a WAN environment or things like that, where you've got maybe a branch topology. So just kind of building on that same principle, right? Just extending that concept into NSX and the data center.
Yeah, all I'm doing right now while you were talking there is just doing some pings and trace routes to show the folks on the webinar kind of what this infrastructure looks like. And it's very, very, you can't tell the difference really. That's the whole idea, is that it's a very faithful representation of the network protocols.
Absolutely. And just real quick as another reminder for folks, if you do have questions about what we're talking about, the Q&A is right there at the bottom, and you can click on it and submit your question, and we'll get you hooked up with some answers.
Yep, and I'm just driving around a little bit here just to show you what it looks like now that we've made all of these changes to the network, and so that you get to see what once we're totally done, the changes to the network, and how things look. And like I said, it's identical to what you're used to doing now. And the thing we got now, the beautiful part about it is that you throw on a new layer 2 subnet, you throw on a layer 3 subnet, you throw on a layer 2 subnet, you create your VLANs, or VLANs, see I'm using old terms, you create your IP address, you create your IP address scheme, you attach that to a DLR, the distributed logical router, and then now OSPF, which is where it starts to really show its power. Boom, boom, boom. You add it there. You don't have to do you don't have to do HSRP anymore. You don't have to create any additional VLANs. It's just going to be available to the rest of your network. And you're like, hey, you know, what about the firewall? That's where we had covered it a little bit earlier. In that, from a firewall perspective, you don't have to make any of the changes. You can make them with the distributed firewall that we have. And just for the you know, trying to keep our so that I don't turn a 1-hour webinar into a 2-hour webinar, I wanted to give you you know, bringing it all together really quick. And this is showing you the physical network down at the bottom. You can add, you know, now that we've standardized the physical network, we can add whatever we want to as the logical network up on top, and it will be available to the physical network on the bottom. So this is just showing a host on the I guess the bottom left, and another ESX host on the top right, where they don't have to be either in the same rack or anything like that. We add a subnet to one side, and it becomes available on the whole thing. And you know, when they're wanting to exit the environment and go into the physical environment, they can use that path to take them on out. Just works. And I wanted to throw this in here since I like running out of time and stuff, and you know, I could actually start another 45-minute one just doing the BGP. I wanted to cover it really quick for you guys. Is that, you know, here was our area, you know, 100. Is that, you know, this is what we were working with earlier. You know, turn it into a normal area, and you don't have to touch area 0, because what you could do is, as an alternative, is you could put BGP on the edge and do a BGP peering up into your physical network. What made this one kind of a little hard to do for webinar is that the distributed router, just to make the distributed logical router, just to save you from like really hurting yourself, it won't let you run 2 routing protocols on the distributed side. It will on the edge, but not on the distributed. So you'd see me like for 5-10 minutes converting the network over. So I figured it was quicker just to show you in a diagram where you have like 65513 to 65512. That but as long as you're in the same AS, that's IBGP, and then it does an EBGP peering up to the like for my router 1 and 2, and then 14 becomes router 4. And one of the things to keep in mind when you start doing it, doing large scale, is I put a route reflector on router 3, which means in a normal and an IGP peering, you have to have a full mesh. The route reflector, when you look at my configs, is gonna, I'll have a route reflector there, so that makes it so that I don't have to peer router 1 to router 2, and you know, and show it that way. But let me for the interest of time, I'll move on to this one. If we have enough interest, I'll make a separate one dedicated to you know, nerding out with the BGP side. And you know, starting to take you again into what we have available inside of NSX. It's just not just slideware. We are a faithful reproduction of network security and services. I mean, in software. So we just touched on one of the small parts, which is the connectivity to physical networks. But we also have load balancing. I mean, it has its own edge firewall. I mean, there's just a ton of features that we have available that you know, you can cover, as Ron had mentioned earlier, in our hands-on labs. We have tons and tons of labs to walk you through how to do all of these options.